Good to have you back, Logan. For today's installment of Math from Your Couch, what we're going to do is we're going to take a look at transitioning from geometry into algebra. So we're going to be focusing a little bit more on topics of Algebra 1 and kind of previewing what you're going to be seeing in Algebra 2, because there is a transition between those two types of maths. Yes, we use a lot of algebra in geometry, but we don't use everything, and I want to kind of explore some of the ideas we learned in Algebra 1 and extend it for what you're going to see next year. The first thing is we're going to take the topic of circles and we're going to transition into how to graph circles algebraically. And it starts with understanding that this is the standard form of a circle. X minus h to the power of 2 plus y minus k to the power of 2 is equal to r to the power of 2. So we're going to look at the equation of a circle and graphing circles through three lenses. The first lens is going to be the idea of the equation. So what does the equation look like? Then it's going to be talking about the transformation and how the equation references the transformation and how that's going to help us interpret the graph or what the graph is going to be doing. And then the final one is how does the graph look? And you can use any of these three to find the other two. And that's the idea, is they all work kind of hand in hand with each other. So our first example is going to be x minus 2 to the power of 2 plus y plus 1 to the power of 2 is equal to 25. And all we want to do is just make sure we understand the relationship here. Now, anytime in an equation you're going to see a minus a variable, so minus h, that just means the opposite when you see it in numbers formed, right? So over here I see minus 2. That doesn't mean the 2 is negative. That actually means it's the opposite because the equation says to take the opposite of what you see. That's kind of the interpretation that's going on there. Now, this number here, this h, is changing the x. So that means in this equation here, the 2 is changing the x and the 1 is changing the y. So our understanding is that those two numbers, the 2 and the 1, are going to be changing our x and our y. Now, how it changes it, that's going to be based upon our understanding of this equation right here. So what we're going to do is I'm going to say that there are two directions that we can move. We can move in the x's direction and we can move in the y's direction. Now our x is going to move in the left to right direction and our y is going to move up and down direction. So I'm going to write left to right. All right, so left to right. What we have here is opposite of negative 2. We have a slide or translation of 2. So we're going to go 2 positively. Okay, so we're going to go positive 2. So that's what's going to happen in the left to right movement. And then our up and down movement. Up and down movement, you'll notice that it's opposite of k. So we're going to go the opposite of what you see. We're going to say that our up and down movement is going to be minus 1, which is going downward. So we're going to move 2 to the right and we're going to go down 1 space. Now, as far as this specific topic of circles, what this tells us is that our center, okay, our center of our circle is going to be located at 2 comma negative 1. So using this equation right here, you can say that the center of the circle is at h comma k. I would rather just have you understand that that's how the movement goes, and then that movement determines the circle. So the center of the circle. So if I wanted to, I can now graph it. I can go 1, 2, down 1, and that right there would be the center of our circle. Next, we now need to look at this guy. Now, this guy is going to tell us our dilation. That's the general understanding of what's going on. But the specifics to the circle is that this is our r to the power of 2. So that right there is r to the power of 2. So I'm just going to write down r to the power of 2 is 25. Now, to solve for r, we're going to square root both sides of this equation right here, and we get r is equal to 5. This is our radius, okay? So our radius of the circle. So the larger this number gets, the bigger our circle will get as far as radius is concerned. And the smaller it gets, of course, then the smaller our radius is. Dilation means to expand or to shrink. So we're going to dilate this by a factor of 5. That means it's going to be 5 times larger than the normal circle. So we're going to go over 5 spaces. 1, 2, 3, 4, 5, which is about right there. But we're going to go 5 spaces in 4 directions. We're going to go to the right 5. We're going to go up 5. 1, 2, 3. 4 and 5, and we're going to go to the left 5, 1, 2, 3, 4, and 5, and we're going to go down 5, 1, 2, 3, 4, and 5. All right, so you'll notice that all 4 of those points are 5 spaces from the center of our circle, and then we're going to just connect those 5 points. And when we connect them, we get the circle centered at 2, negative 1 with a radius of 5. Sorry, that's off just a tad, so I'll make sure that those points are all seen. All right, and that's our first example. Taking a look at our second example, what you guys will notice here is that our center is now located at negative 2, 3 with a radius of 3. So let's go to the graph part and then let's talk about the equation because I think that we can focus on the graphing. So center is at negative 2, 3. Notice it's not in the equation format. So since it's not in the equation, we just take that information and graph it. So we're going to go to a center of negative 2, 3. So we're going to go 2 spaces to the left, 1, 2, 3 spaces up, 1, 2, 3, and we get this point right there. Next, we're going to go by a radius of 3. So that means 1, 2, 3, and then 1, 2, 3. All from the center, 3 spaces in multiple directions, and then 3 spaces down as well. Next thing we want to do is connect those points right there, but we have to dilate, we have to change the size of our graph to right about there, and connect our points. And there is our second graph. But on this problem, something I want you guys to do a little bit different is I actually want the equation. So what we want to do is we want to set this up. So now, if the center is at negative 2, that means we shifted 2 spaces to the left. So we're going to go opposite. So we went 2 spaces this way, right? That's a negative 2. That means in the equation, it's going to be plus 2. So we're going to write that. We're going to write x plus 2 to the power of 2. So that's our shift to the left. So when we go to the left 2 spaces, we're going to make sure that it says plus 2. I know it's opposite, but that's because that's what this equation says, the opposite of whatever h is. In this problem, h is negative 2, so over here I have to do the opposite of that. So we can say that h is negative 2. That means in our equation, it's going to say x plus 2. Now you'll notice that k is equal to 3, so I can write that k is equal to 3. So that means in our equation, it's going to be the opposite of that, plus y minus 3 to the power of 2 equals. Now this is where you got to be real careful because a lot of people will mess up on this, including myself. This is our radius. Our radius is equal to 3. If you write a 3 right there, that would be wrong because that's not what the equation says. The equation does not say r, all right? It says r to the power of 2, so I need to rewrite that. So if r is 3, then if I square both sides, this means r squared is 9. This equation is equal to 9. All right. So those are the 3 things interacting with each other. All right, let's take a look at another example. On this example, we have the actual graph. So what we want to do here is just make sure we understand what's happening on our graph. So I'm going to count for the center. So it's 1, 2, 3, 4, and then 1, 2, 3, 4. We're in luck. We have a center located at 4, 4. All right, so this means that our h is 4 and our k is 4. And if you want to take that, you can write your equation. So we can start writing our equation. We can go x opposite of h minus 4 squared plus opposite of k, y minus 4 squared is equal to, and we just need to figure out the radius. 1, 2, 1, 2. So our radius is 2. All right, so we dilated by a factor of 2. Once again, that type of language is not necessary for algebra, but that's what's going on right there. So we have r is equal to 2, so if we square both sides, we get r squared is equal to 4, so then we can write equals 4 right there. And very quickly, you can see how these two things are interacting with each other, the equation and the graph. The transformation is just a bridge between those two. It's kind of the words that we use to get from equations to graphs and graphs to equations. All right, taking a look at our third example. What we have here is we have, once again, another graph. So what we're going to do is we're going to find the center of this graph. So it's going 1, 2, 2 spaces to the right. So I'm going to go negative 2. So our center is located at, that makes no sense. Our center is located at negative 2, 0. So we can say that our h is negative 2 and our k is 0. So our k is nothing. So we can write our equation. We can go x opposite of negative 2 would be plus 2. So we're going to go x plus 2 squared plus, and then now you'll notice that there's no shift on the y, so we can write just y squared. You don't have to write minus 0 or plus 0. You can just write the y is equal to, and now we need to figure out our radius, so we just count. 1, 2, 3, 4. Just double check up and down. 1, 2, 3, 4. Yeah, we got a radius of 4. So r is equal to 4. Be careful. We should not want to write 4. Well, we might want to write 4 there, but that would not be the radius. That would give us a different radius. Remember, it's r to the power of 2, so we're going to say that r squared is 16. So we're going to square both sides to get r squared is 16. So we're going to write a 16 right there. All right, moving into our last and final example. What we have here is x to the power of 2 plus y minus 3 to the power of 2 equals 1. So I'm going to start with my h and my k. In this problem here, you'll notice that nothing is being added to x. So we're going to say that our h is 0. So h is equal to 0. And then k, opposite of that right there, is going to be 3. So we can now deduce that our center is located at 0, comma 3. Now, if you wanted to start graphing this thing, you could. So we're going to go 0, no direction left, right, and then we're going to go 3 spaces up, 1, 2, and 3, and we put our center right there. Next, we find that our r is equal to 1. So r is equal to, sorry, that's not our r, that's our r squared. So r squared is equal to 1. So this, remember, is the r squared. So then we're square rooting both sides of the equation. And this gives us r is equal to 1. So we have a radius of 1. So we're going to go 1 space to the right, boom. 1 space up, boom. 1 space left, boom. And 1 space down. We take out our circle. Now this one here is a unit circle, a small one, I mean. So I'm just going to kind of make my, I don't know, my floppy circle. I don't know what to call that other than deflated, maybe. Maybe do a deflated circle. So this right here is essentially how it's going to be working. Please make sure that you do the best you can on this assignment here. If you have any questions, show up during tutoring or send me an email. You can also hit me up on Google Classroom. And I wish you guys the best of luck. Talk to you guys soon.